The figure shows the graphs of four functions. One is the position function of a car, one is the velocity of the car, one is its acceleration, and one is its jerk. Identify each curve. Now, just to go back here, the jerk function is also known as a jolt, surge, or lurch, is the rate of change of acceleration. That is the derivative of acceleration with respect to time, and as such, the second derivative of velocity, or the third derivative of position. So let's first take a look at the graph of A. Now if you notice, there's a high point for A and there's a low point of A, but it does not apply to an x-intercept on the graph. So we can immediately say that that's going to be the jerk function. But then also, if we look at the graph of B, we can see that there is a horizontal tangent there that applies to an x-intercept on the graph. So therefore, we would then say that B prime, would represent A, which is the jerk function. So if that's the jerk function, then we would have to say that B would then represent the acceleration function, because the derivative of the jerk function is the acceleration function. So let's take a look at B. Now if we take a look at B, we can see that eventually it hits an x-intercept over here, and therefore according to the function C, we can see that there is a horizontal tangent there that has an x-intercept there. So let's take a look at the horizontal tangent at C, and it has a x-intercept here. So therefore, we would then say that C has the derivative is equal to B, and again, B is going to represent the acceleration function. Which then means what? Well, if C is the derivative of B, then that means that C would be the derivative for D. So that means that the derivative of D is going to equal C, which is the velocity function. And if C is the velocity function, B is the acceleration function, and the jerk function is A, then we would say that D would then represent the position function. So let's go ahead and talk about this. So again, A must be the jerk function since none of the graphs are 0 at its high and low points. A is 0 where B is a maximum, so therefore B prime is equal to A. And we can see that B, the graph of B is 0 where C has its maximum, so therefore C prime is equal to B. And then we conclude that D is the position function since C is the velocity function, B is the acceleration function, and A is the jerk function.